So yeah, yesterday you talked about something. I don't know what you can remember from yesterday's conversation that you had. So I'm going to just give me 1 minute review of what you did yesterday, despite all those the technical hitches that maybe sometimes happen. Uh, what did you understand from yesterday's conversation? Let me get from Aloch. Evita, did you? What is just one thing that you understood yesterday? Your microphone is on mute. Maybe as the ship prepares. Said, what did you glean from yesterday? Maybe one or two things, or even five. Said, microphone also on mute. Continue.
So yesterday was all about data cleaning. Uh, so in data cleaning, we can remove null values from the data, either from the rows or columns. We can remove the whole row for if it has null values, and also we can omit null values from data or from rows or columns that have instances of null values. I think that's
Yeah. How about let me see. Let's get Nathan. Nathan, for you, what did you get from the conversation yesterday?
Okay, cleaning the data, filling the missing values, and the null values. Yeah.
Yeah. So that is basically what you are going to review, and of course, data cleaning and the importance of data cleaning. Have you ever come across an analysis, or maybe you've done analysis using a data that is not clean? Anybody who can share the experience? If you have ever done any analysis with the data that is not clean, you can see missing values are there. You can, Alvin, you want to share?
Um, yes, I have, but not with R.
Yeah, whether with SPSS, NVivo, Excel.
Well, what I can say is that I've used quite a few, like Python, SPSS, a bit of VViews, and also advanced Excel. And the challenge is that we know when you come to the forecasting part of it, that is, I think, machine learning. For example, for those who know Python, it becomes a challenge because you find that you try to get a normal distribution, which is usually the widely recommended. You find that even the skewness is affected, and when many points are variating from the mean, it tends to affect the end output. So it becomes even coming up with the final report more difficult.
Yeah, that's good to note. Anybody else who has had experience using data which is unclean or data which is not clean? Victor, have you that experience?
Not yet.
Not yet. Yeah, okay. You need to look for a dirty data and try to doing any kind of analysis, and you come back and tell us. But
Okay.
one of the things that Alvin you mentioned is the fact that skewness. Uh, One of the effects of having maybe outliers in your data is that it will tend to uh, skew the data towards them. For example, let's take a case where you are looking at the GDP of maybe Kenya, or maybe take the GDP of even the whole world, right? And you know that the top 4% of the whole world has like top 4% of the richest people in the world, like has more money than most. I don't know. There's that statistics that I'm trying to remember, but top 4% is actually very wealthy. If it's not top 4%, it's top 10% of um, the rich in the world, the filthy rich. They have actually more assets or maybe more money or than the remaining percentage, something like that. But I maybe check for that information. But it's that huge. I mean, or maybe the statistics or the percentage is that small. So tend to think of a case where you are trying to calculate the GDP of 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 the world, right? And then you know very well that the top 4% or maybe the top 10%, yeah, I'll use quotes to mean that I'm not sure of that statistics yet. But taking an instance where you are calculating the GDP and then you realize that maybe the GDP is very huge, and then you conclude that people in the world are actually wealthy, right? But it is because maybe those outliers, like those people who are on the top, right, actually are dragging the others are dragging the others to towards them. I mean, right? Um, there's sometimes maybe an instance even in high school or maybe when people are performing in their classes, and then you realize that there are those people who really perform very well, right? So that when you get the average maybe is around 50 or 60, right? Because a certain percentage of people scored 90s, and then a large percentage of the class actually scored even less than 50, right? With some sporadics in 70 and 80, maybe one or two. When you get the average, you maybe get that the average score, or maybe the average score of the whole class was 50, was 57, or maybe it was 60 or something like that. That most of the people are around 60, but maybe you can find that there's a huge percentage of people who really are even in their 30s, right? Sometimes like outliers tend to drag part of the data with them, and that is one of the effects of maybe not cleaning your data. So you will be reporting something that you'll be reporting something that is basically not true, unless maybe you go further and dissect it and maybe group people in terms of maybe their levels of earning and things like that. Yeah. So that is one of the effects of maybe having data which is not clean. But again, the purpose of data cleaning is just to help you eliminate the errors, eliminate redundancy. Redundancy is more of like you've repeated things, right? Accuracy, you want to ensure there is accuracy, and data consistency is also something, and just you're assured of completeness, right? And things like that. So I think that is something that you covered yesterday. But one of the things that you want to increase is your precision, right? Even when doing the analysis, your focus is more of on the precision part. I think this is a code which I don't know whether you did run it yesterday, but I don't know what you wanted to achieve with it. I've not checked it. Let me draw this. Okay. So this is just a line of code to import data, right? I think this one is something that we did in the past, right? Yeah, because I'm not seeing that it has been used here. So I'll just talk about this other one. So handling missing values in R. missing values is one of the things that I think yesterday we talked about it using na.omit, right? But na.omit is not really advisable because you'll be losing your data so much. You'll be losing most of your data, and also that it will compromise on the precision that I was talking about, like how accurate is your analysis. If you're going to be omitting, if one row or maybe one case had just one missing value, another one had two missing value, another one did not have, another one maybe had just three missing values, and you have maybe like even 50 columns. So if any row has a missing value, it is removed. That is like na.omit. So you might end up like out of 385 responses, you omitted like even 100 responses. So you have like 285. And if the sample size that you are working with was 385 of a population that maybe is something like if you calculate that, you can be having like a population that is 2,000. Now you're working with 285 responses. So the sample size is actually less than the initial sample size that you had. So even if you are going to be making inferences, it is inference that is really not accurate because of the fact that you had to omit some of the values, or maybe some of the respondents that you had. So what I mean is we looked at na.omit, but it's really not advisable. Na.omit this kind of function. But anyway, we are going to look at it hapa mbele. So I hope you can run this code, right? So if it has those hashtags and things like that, just remove the hashtags. I don't know whether you did run it yesterday. Did you run it, Pashamai? Yes, Kinoti, Evita is around. I'm seeing you are asking for Evita. Did you run this code like the way it is this way? Oh, yes, you did. Okay. Okay. So we can just maybe rerun it because we want to talk about it. So if you rerun it, of course it's running, and then you view your data, you can see what you have here. Number 1, 2, up to. I think this one, I hope this of course is not a problem, right? Victor, iko sawa, right? Unmute kindly.
Yes.
Okay. Who else is not at this point where I am? You can raise your hand. Uh, okay. The fact that no hand is raised, then you're okay. Yeah. So yesterday you looked at that and tried to do, of course, if you run this, what it's telling you that argument is not numeric or logical. So here you are supposed to pick maybe a certain column. So if it's you want to get a mean of maybe x1, let me have these things as x2 because it's going to write it as x point something. Yeah, x point 1, x point 2. I don't want it that way. So this one is x3. Then I can run it that way. Then this. And then if I get maybe mean of a column like x1, right? You'll get that it's telling you NA. So it is telling you this way. Let's see here. Because of the fact that we have some missing value, 7, 10, so it cannot calculate it when the missing values are present, right? Okay. Yeah. So how can you handle these NA values, right? So this is a recap. So mean, of course, you specify the column that you want to use. So for example, here we cannot find the mean because of the missing values. Now, how about if we omit the missing values and then calculate the mean? We can go back to calculating the mean of x1. that is the data we are using. Even if we could have named it something like even Evita. Of course, I'm using Evita because people have asked where Evita is. Is Evita around? People here to mean Alvin. Um, so mean data x1 and then na.rm equaling to true. If you run it, you get that the mean is 12,501.5. So what it actually does is to add 1 plus 2 plus 3 plus 4. That is what? That is like 10. Then plus 1 plus whatever, that is 13. And then you add with this and then divide by 8 because we are not using number 10 and we are omitting number 7 also. So that one you get the answer to be, sorry, you get the answer to be 12,501.5, right? So imagine again how this outlier is lying to us, right? Or maybe, of course, it's not lying, but it is pulling values towards it. Yeah, this is what I was talking about that time, right? That if you have extreme values, suppose in a village you have collected monthly incomes of people, and then there's that one rich guy in the village that does, even if it's wash or something, or maybe just works in one of these ministries or something, and has a monthly income of maybe 1 point something million, right? Or take an example of maybe those people surrounding the locality of the president, right? So prezo ako hapo, monthly income yake, if ongeze za kuku, ongeze za deals here and there, ongeze za all those monthly incomes, and maybe you get that per month is raking in like, let me say 20 million, and then now you have all the villagers around again. You want to get the mean monthly income of the people of Sugoi, right? Just maybe the village, you go up to the village, maybe the village is called something else that I don't know, but out of 100 or maybe 10 villagers, then you collect that information and try to get the mean, and then you end up that the mean is actually maybe even 5 million. From from the look of things, you can say that these people are really rich. They don't know what is called shida or something, but it is because there is somebody pulling the data towards themselves, right? And that is what this 999 has done here. You can see that you have 1, 2, 3, 4, 1, 1, 1, which if we try to omit this value and get the mean, it will be 1, 2, that is 3, plus 3, that is 6, 10, 13, divide by what? Divide by 7. 13 divided by 7. So it's actually 1 point maybe 9 apple. Yeah, 1.9 something there. But now because we have 99,999, then the mean score is now 12,501, and that is the downside of having an outlier. Away from that, we are talking about how you can calculate mean now by omitting the missing values. So if you have it as na.rm, what does this na.rm stand for? Because you can be saying it as na.rm. Now, gee, what it means. Somebody to say what na.rm means. Somebody to volunteer. Very fast, quick, fast minus slow. Stella. Stella, what does this na.rm mean? Yeah, hi. This na.rm is equaling to true. You have no idea. Yeah, so who has an idea? Yes, ama hii kitu tunasema na hatujui ni nini? na.rm.
na.remove.
Yeah. So this is a function that is used
null
to. Sorry.
false.
Continue. Hubert. Hubert, just continue. You unmute and speak.
I'm saying it means to remove null numbers.
Yeah, so this is just like ENN for the nulls that you are having here, right? So it's just a function to remove. So if you say that it is true that they need to be removed, then they will be removed. If you say it is F, of course you can write false in full. You can write F not available, remove. Yeah. So basically, it's a function to remove the null values that we are talking about, the NA. So it is good to remove the NA values, and then so if you run it, you'll actually get this value. But initially we could not get it. If you run this first one, we could not get it because of. So if you have NA values, that is how you can do it. I don't know what you wanted to do here with summary data, but yeah, summary data. This just, of course, to just give you a high-end summary of this, of the data that you're talking about. So maximum value 999, minimum first quartile is 1.0, and then third quartile you are being told it is 3.25. So it has actually omitted 999 in calculating the quartiles. Yeah, because this one is an outlier. So when you plot a box plot, when you plot a box plot using NA, using X1, you will find this as an outlier, similar to this thing here, similar to how you will see this. You can see this this one. What do you call this? Your cadot that is telling you that we have an outlier. Let's go to another thing that you're talking about, data cleaning operations. So after checking the summary of the data set and we found the number of NA in various columns. Oh yeah, you can see here that the number of NA values here is 2 in column X1. Column X2 we don't have any missing value. Let me see. Column X2. Oh, it should be. Oh, okay. These ones were not added as NS. Let me see what you wrote in the line of code. Yeah, so these ones were not NS. They were not missing values because they are actually entries there. So they are not missing values. The missing values that you have is this NS here, which are not strings. So in X2, there is no missing value. X3, there is 1, right? There should be 1 missing here at X10. X4 we are having just spaces, and X5 we are having NS to be 10 here. X4, X3 should also be having this as 1 here. So yeah, that is a summary of the data of the data that you have there. So after doing that, we can get a clear visual of the irregular data using box plot. Yeah, so box plot though you can even use to show the irregularity. So let's look at this air quality data set. So you can also write this to view the air quality data set, how it looks like. So this is the air quality data set, and actually it has some NS in ozone. Yeah, you can practice with this data to remove these NA values. You can see NA or calculate the mean of maybe something like solar.R, but omitting this NS, right? Of course, that is something that you can do. You can even write it here and say we want to see the mean of what? Air quality solar.r. We want to see solar.r, comma, na.rm equaling to true. And then you can see it's 185.93. If you have this as false, then you will see Na. I hope we are okay there. Evita? Okay. Evita is. How about Eric?
I'm fine.
Cool. Now, let's talk about this removing irregularities with this is na dot is dot na, I mean, method. So so here, do you know what this line of code mean? Line 641. Who can tell me what it means? You can run it even in your line so that you tell me what this one mean. Actually, it's not. I'm just trying to see if you understand what the codes are talking about. It's not anything very huge or out of this world. I mean, right? Pashamai, do you know what this means? Nkoitoi, who can tell us this thing? Hubert, what does this line mean? Yes, of course. Here we are just duplicating.
Pass.
Pass. Yeah, here we are just duplicate. We had this data that we had created here. Data, right? We had this data that we had created here. We are just duplicating that data, but giving it a different name, right? I can even say it's not something fancy. I mean, this is just something simple. There's some maybe I don't want to use this name data, but I want to equate it to even another name like info minus, right? I want to call it info minus. Control enter. So that if I view info minus, the info minus, right? And you can see it is just the same thing that we had, right? Sio kitu ya kushtuana. Are we okay? Thumbs up kama tumeelewa what I'm talking about. Aloch haujaelewa. Aloch, tell me where you're why like mali unapata shida. Just unmute. Aloch, you don't want to unmute. Oh, my mic has issues. Yeah, but I mean, if we just say that in a new df is equaling to data, I am just creating this data a second time, but giving it a different name. Sio lazima angefanya hivyo because that is what I'm seeing he did. I can even call it. Okay, let me say what we created here was data, right? I can write it. I want to create something else because I want to use that name instead of using data. Instead of using data, I want to use a different name for easy operations zenye tunataka kufanya, and that's why I created. Let me create it with a different name called new data frame, right? And say it is equaling to data. It's similar to maybe I don't want to use iris, but I want to use that iris dataset, but I don't want to use the name iris. I want to use it with a different name. So what R will be understanding is that there are two different kinds of dataset. So it will not be affecting operations the data that is having a name data, but it will be affecting operations using like the data that has new data frame. So hii tunataka ibaki to the original venye ilikuwa. So we want to use with this one, not this. But they are actually the same kinds of data. I mean, right? So that even if you have something like, of course, you know that we have iris dataset. Yeah. I may not want to use that iris so that ni haribu. I may even call it Zakayo, right? And say Zakayo is equaling to iris because he wants to scan iris of watoto wadogo. Yeah, so Zakayo is equaling to iris, right? So that if you check, if you view iris, sorry, if you view Zakayo, you will see that we have like the iris dataset. So operations will just be affecting this one, not the iris. Cool. So so if you view this, you'll just be getting this data, right? And then now we want to remove irregularities that exist in our dataset. So in your code, I believe hapa imeandikwa like new data frame column, if else, new data frame column again, right? Yeah, but that column is telling you like find a specific column that you want to work with. You want to remove the irregularities, but find a specific column. That's why nearly change to, let us use X1. X1 is this column here, this column that we have here, right? Of course, hii ni kama like already let me run the code afresh. Let's see.
Excuse me, Boniface.
Yes.
Could you possibly, share that piece of code for the new DF $ column?
It is in your codes, right? Just do editing.
I think I must have, rubbed it off yesterday, kimakosa.
Yeah.
Yeah.
No, but I sent the new codes. I sent the codes kwa the classroom, like in the what? The WhatsApp group, right? But Control Z. Let me just. What have we done? Okay. Yeah. So this one. So because I'll be doing copying every time, and that is why I'm trying. I'm telling you that you can just download it so that because there are changes that I've done here, so we'll not be doing the copying every time. So download the one that I shared so that you use that, right? Is it okay, Alvin?
Okay.
Okay, thank you. Yeah. So we want to use the if else. Yeah, this is like a loop function. If you talked about loop in no, not loop, but yeah, it's basically a loop. Yeah, we have for loops and we have different kinds of loops. This one is also just trying to loop. It's going through your data. If it meets the condition that if it satisfies the condition that you're checking, iterates again and again and again until it finds whatever it is that you're looking for. But I'll explain to you like what every component means. So what are we trying to achieve here, right? If you run this column, let's first run this new df and then run view new df. So if you view new df, this is what you have, right? And then if you run this one and then view new df, so before we view it, you can see that there are missing values number 7, there's missing values number 10, right? We have the missing values. If you run this one, if we run this line of code 645 to 648 and then view what is up here, let me see. Yeah, there's a problem here. This one should be x1. So let's run it and then view. Yeah, so if you view, what are you seeing if you view that data? The x1 now. Can somebody tell me what they're seeing? Very fast. We have a few minutes. Victor, what are you seeing? What has happened? Yes, Victor? Yeah. But Victor is saying that the NAS has been changed to 1.5, right? You can see something here. We included here that median column that we are using is x1, right? Comma na.rm is equaling to true. So if we write na.rm is equaling to true, if we find like a missing value or an NA in our data set, if it is true that we have one, right, then we replace it with the, sorry, let me first, let me copy for you this thing and then you see it first before I give a different explanation to what I wanted to say. But let's say this is X. So if you run X, is this 1.5. So what this value is getting here, it is getting the median of our column, X1, right? The median of our column X1, the median. I hope you remember how median is calculated. So it is getting the median of our column X1, right? Which is, it is finding to be 1.5, right? So if we find any missing value, is there any missing value in x.1, like in x1? If there is any missing value, then it is replaced by the median. We replace it with the median of our column, right? Of our, if it loops through this and finds if there's any median, if there's any missing value, then we'll replace it with the median of the whole of this column x1. There is an instance where you can replace a missing value by the median. You can replace a missing value by the mean, right? You can even replace the missing value by even the mode, right? Take an instance where you are doing a data of the column is gender, right? and then you look at your data and you find that maybe 70% are female, then 28% are male, then there are 2% missing values, right? You will tend to think that because there are so many females, then this data, we can replace it using the mode, right? So there's an instance where we can replace, we can even change this one to mean, right? And run it and view now our, if you view it, sorry, what have we replaced it? So, oh, of course, yeah, we are replacing it with 1.5. So it is not going to use 999 point that while creating the median, while calculating the mean. You know very well that median is always the the Q2, right? The third quartile. But median of the value is actually, is it the mean? Because median should be this one. Median should be this black spot that you're seeing here. So this one is Q1, this one is Q3, this one is Q2, which sometimes is just the mean of your data, right? So that's why even when we use mean here, the value that is being returned we have is still 1.5. You can see number 10 and number 7, 1.5. So it is going to look through, and if it finds any missing value, it is going to replace it by the mean, or we can replace it using the median, right? And then if you run, so if it finds any missing value here, it replaces it with mean, else just return the values. So we are using if. So the if part applies for if it finds a missing value, replace it with median. So the else part is this one. Otherwise, or else, just return the values that you have in your in the initial, the values that are not missing. I mean the values that are there. That is the else bit for this part, the last part. Have I confused anybody? I hope not. Did you talk about that yesterday? Alvin?
No, I can't really remember that one.
How did you cover this yesterday? Nathan, you covered this yesterday, right?
Yeah, but at least you have added some salt.
Oh, some salt was missing. Yeah, okay. Sawa. So that is
Yeah.
okay, thank you. That is how you can replace using a median, you can replace using a mean, you can replace using a mode. So just try to understand what I've described here using this if else. Okay, let's go to another thing. You can even see here. Here we are replacing the missing value of the first column with the, I don't know, maybe I removed some chunk there. So if you do a summary of the new DF, you can see what we have now. Median 1.5. Mean now calculating it using this one, we have it as 101.50 something. Yeah. And we no longer have any missing value in this column now, x1. Yeah, let's go to removing empty rows. We sometimes have empty rows. So this one, I mean, it is completely empty, or empty. Some people will say it's empty. Yeah, those are, I can even remove this to be this way, and another thing. Okay, so you can see what I edited. I wanted the first rows to have NA, like it to be completely empty, right? That is where this concept that you're talking about is going to work. Now, if you run this, control run, and then you view data, you will see that row number 1 is completely empty. Of course, column number 5 was also empty. So that is where I want to explain to you this concept. So we want to use this line of code to drop the missing rows. I mean the empty rows. Yeah. So we use what is called row sums, right? So row sums, it is going to sum, or it is going to calculate the number of NA values for each row. So it will go through this row and calculate how many NA values are there in number 2. That is what row sums is going to do. And it will look through and find that for row number 2, there is only 1. And again, it will be comparing it against the number of columns that we have. So we have one missing row out of 5 columns. Sorry, one missing value or entry out of all the 5 columns. So, or we have one missing column for row number 2. So that is 1 out of 5. It goes to number 3 and sees that we have 2 out of 5. Goes to number 4, 1 out of 5. But that is what row sum is doing. Goes to number 5, 2 out of 5, 6, 1 out of 5, 7, 3 out of 5. This one is not NA that we are talking about. This is a string. This is a missing. Goes to number 8, finds 1 out of 5. Number 10, 3 out of 5. Goes to number 1 and finds that we have 5 out of 5 are missing. That is what this row sums is doing, right? So we are saying row sums, and then bracket is NA dot .na data. So data, this is the name of the data that you are working with. Suppose it was new DF. That is what you could be having here. That is the data that we are also using here. Actually, this is the concept of subsetting. You can see this, the square brackets. We had already talked about them, right? That is called subsetting. So I'm actually giving it a different name, data.1, so that you don't confuse. Yeah, so I've really talked quite fast, but you can see that row sums, what row sums is .na data. It calculates the sum of NA values for each row in the data frame, right? Then there is this part n called data. It gives you the total number of columns in the data frame, and I have explained it hapa, right? 5 out of 5. So imesum rows ikapata 5. Total n call data is now giving you the total number of columns. Yeah. So n call data gives you the total number of columns in the data frame, which is used as reference. Then there is this one. Now the whole of it, row sums is not equaling to n call data or something of that sort. So it compares each element of the vector obtained in step 1 to the total number of columns. That is what I said with 2 out of 5, 3 out of 5. So if the number of missing values in a row is not equaling to the total number of columns, is not equaling to the total number of columns, you can see this is the sign for not equaling to. It means that the row has at least one non-missing value. Take time to digest that, i.e., it is not a completely missing row. So the result of this comparison is logical vector where true indicates with the non-missing values and false indicates rows with all missing values. So R itakuwa inajifanyia hiyo kwa akili, right? Yeah. So it will be doing that comparison here. So itakuwa inajiletea that maybe for 1 it is F, for 2 it is true. So it is true that the number of rows is not equaling to the number of column. Yeah. When I say the number of rows is not equaling to the number of column, you know that the number of missing entries, right? the row sums, I mean, is not equaling to the number of columns that we have. So that is what it is doing. Yeah. So if you run this code, of course, this one is just to show that it is rows, right? That you're working with here. If you run this code and do a data.1 here to view, you can see that it has omitted row number 1. Nani amepotea hapo? Put up your hand if you are lost. Alvin is lost. Stella Mudhoni, tell me where you're lost. Yes? Stella, are you okay? Rudia tu tafadhali. Hubert umepotea. Hubert,
Yeah.
where?
Place
Where?
ulikuwa una explain hapo the number of rows is not equal to columns.
Okay. Alvin?
I think hapo penye hiyo nini inasemaje, this column, the row sums is any data is equals to that with the not equal to operator. From hapo nimepotea.
Okay. Okay. Let's investigate row number 1. Let's go with row number 1. So row 1. Row ya kwanza. Row number 1. Okay. So I'm asking you a question. How many values are missing in row number 1? Yes? Stella? 5. Okay, yeah. So we have 5 missing values in that row number 1. How many columns do we have? How many columns? Alvin? How
We
many
have 5 columns.
Yeah, we have 5 columns. So this one is row. We can say 5 is equaling to 5. Sindio?
Yeah.
Then we go to row number 2. How many values are missing in row number 2?
We can say 2.
It is 1. This one is not a missing value. This is a space. It's not missing value. So 1 is missing. So we have 1 missing row. So that I'm doing row sums, right? It's NA data. So I'm focusing on NA. How many values are missing, right? 1. Is it equaling to 5 for the number of columns that we had? Yes? I'm asking somebody. Said, we have one missing value. So is it equaling to 5? Aja. Alvin, is it equaling to 5? 5 on this side is the number of columns, right? N col. You can see here N col, number of columns that you have.
It should be 4. It should be 4.
Forward.
If we have one missing value, then we have 4 columns.
We have column number
Which
1,
which
column number 2, column number 3, column number 4, column number 5. This one is not a
yeah.
missing value.
So the NA is the one that is missing.
Yeah, so row sums is the total number of missing, the total sums of entries that are missing in that row. Then you compare it against the total number of columns, right? It is doing a row summation of values that are missing in that row. So for example, we've looked at number 1 and see that 5 are missing. What are the number of columns? The number of columns is 5. We go to number 2, row number 2. Row number 2, we have only 1 is missing against 5 columns. And this one you can say that it is not equaling to 5, right? Go to row number 3, and that way up to row number 10, right? Up to row number 10. Row number 10. You can see here that row number 10, we have 1, 2, 3. 3 missing values against 5 columns. 3 missing values, which is again not equaling to 5. Yeah. So we were saying that row sums, this compares each element of the row, each element of the vector obtained in step 1, which we have done, to the total number of columns. If the number of missing values in a row is not equaling to the total number of columns, it means that the row has at least one missing value, right? So for example, if it finds it this way, this row is not going to be dropped. But if it finds that una miss everything, we una miss kila kitu, utatolewa kwa system. Ushaelewa? Ukipatikana una miss kila kitu, unatolewa kwa system. But ukipatikana like you are just missing one, we can give you a benefit of doubt. Number 3 tumepata tu una miss 3, lakini we have a total of 5, hatukutoi. Tukipata maybe you are missing 4, right? Out of 5, pia tunakuacha. We are not removing you. But kama una miss kila kitu, wewe unafagiliwa. Are we together? Stella? Victor? Cool. Anybody? Evita? Thumbs up or down? Sawa. Yeah, so that is what we are achieving with this line. So you run it, and if you run it and view sasa hiyo data 1 yetu, utapata that number ile yenye ilikuwa na miss kila kitu imetolewa, row number 1. Thank you, that is done, right? Similar thing is done for columns. Similar thing is done for the columns, right? So it checks, of course, the total number of columns that values that are missing per column, and it compares it against the rows. So it will check column number 1, are you missing? So I have, for example, 10 rows. Column number 1, how many are you missing against the total number of rows? Column number 1 is missing 3 out of 10 rows. Column number X1 is missing 1 out of 10. X2 is missing 2 out of 10. 4 is missing 5 out of 10. But ikikuja kwa 5, it is missing 10 out of 10. So it means that this one also is going to be removed. So that is just the opposite of what we had here. So it's now call sums is .na data, then end row data, right? So go and try to play around with this one. I hope this one now haina explanation maybe because you understood that other one, right? So you can see that X5 has been removed, right? Okay. Yeah. Now you can also remove rows with missing data. And hapa ndio nilikuwa naambia about using na.omit. So na.omit itaangalia kama una miss any value, wewe unatolewa kwa system. So for example, imagine for this data that we have here, itapata hapa that you are missing a value. Let me use the initial one that we had, ile data ya kwanza. Let's run this one. So what na.omit will do is, let me run it. What na.omit itaangalia kama una miss any value, be removed. So for example, case number 1, maybe this one was a respondent. Because you are missing here, unatolewa. Case number 2, you are missing a value here kwa x5, unatolewa. Case number 3, so because you are missing value somewhere here, unatolewa. 4, una miss hapa, unatolewa. 5, same. 6, same. 7, same. 8, you are missing a value here, unatolewa. Let's try to run it and see. That is what na.omit is doing. So you can see the downside of na.omit. Let's try and run it and see kama what I'm talking about makes sense. Yeah, unaweza ona hapa 0 rows or 0 length row.names. That is what na.omit does. Na.omit ikipata tu unapata you have any missing value, anything like you are missing it anywhere, it will remove you. As compared to this one, as compared to hii yenye tulikuwa tunafanya hapa ya row sums, it is just removing yenye iko na all missing values. Do you get the difference? Thumbs up, thumbs down if you don't get it. Victor Sangoro, Alvin, thumbs down again for anybody. I'll watch. Up or down? Ama katikati? Up. Stella? Women power. Pashamai, we've not seen you. Vote. Hubert, where do you stand? Said Suma, okay.
The point is at home.
Okay. Yeah. So we have Victor Sangoro and we have Alvin. Let me control run that and then you view this data. Ukiangalia hii, let's do the row sums that we did. Hii. Ukiangalia now, you try to view data, utapata that, data.1. So data.1.ukirun, you'll find that row number 1 imetolewa kabisa, and I hope that one you understand. Or even ukifanya the columns, you'll see that column yenye iko na missing values hapa imetolewa. It's actually because I've used a different thing to save the data, ndio maana bado 1 inaapia hapa. But in real sense 1 imetolewa na the other one imetolewa. That is ya row sums na call sums. It removes you only if you have completely una miss everything. But na.omit, if I have 50 rows, and I have 100 columns, gender, age, earnings, which year did you finish high school, things like that. Are you married, right? Do you have kids and things like so? Those are rows. If you are missing any value, tuseme una miss even moja out of 99, na.omit is going to remove that row. If you are missing maybe 10 out of the 100 columns, you are still going to be removed. So na.omit is really hungry against anything yenye meona like kuna na mahali we unatolewa. Alright? So if it goes here and checks because you are having an NA here, suppose hizi zote umejaza na hapa pekee ndio uko na issue, utatolewa my friend. Kuja hapa kwa number 5 upatikane una miss hii, you will be removed, right? Upatikane maybe hapa katikati umejaza, of course umejaza maybe umejaza even the white spaces, if even the white spaces are also going to be cleared away. Tuseme hapa peke yake umejaza hizi zote and then hapa katikati ndio umeficha ingine haujajaza, you will be removed out of the system. So that is na.omit Victor and Victor and Alvin, right? Cool. Yeah, so because zile zingine tulifagia nini? Okay, yeah, you've seen the white spaces are spared, sorry. The other one tulifanya hivyo because hatukuwa tumefagia number 5 and number 1, hatukuwa tumezitoa, that's why zilifagiliwa zote. But in this case tuseme yenye I have removed the first row yenye ilikuwa bure kabisa and then 5 pia column 5 x5 pia ilikuwa bure kabisa, tumezitoa so that we had so that tulikuwa tumebakisha something like what, so just think of it like tulikuwa tumetoa hii number x5 na tulikuwa tumetoa x1, right? So hizi za white spaces they are not going to be removed, right? It just removes the ns, right? And that's why tukisafisha now that data.na omit itatoa tu zile zenye zilikuwa zimebaki na ns. So hii ya white space ya x4 it's not going to be removed. Another thing is also on removing duplicates. So removing duplicates. What is the duplicate here? So suppose in my value here unaweza angalia maybe what I have right now. We have 2 4 1 1. 2 4 1 1 and something of that sort. So hizi nikisema like we want to remove duplicate, we are going to use the function called unique, right? So you just say data, then pass in the unique, pass data through the unique function. So nikiandika hapa unique, right, and write here data, itajaribu kuangalia duplicates but it cannot find any duplicate. There is no duplicate here because they are completely different. Number 1, hapa kuna 1 1a, this is 1 1 yy, but suppose this one was 1 1 1 and then number 6 also is 1 1 1, then it could have removed one of them and remained with this other one, right? But now suppose we say that ukiweka hivi it will be looking at the row kutoka hapa mpaka huko mwisho and then checking hii ingine kutoka hapa mpaka mwisho, but suppose now we specify and say that it should check it na column number x1, right? Column x1 not found. What do you mean column x1 not found? X1 unique data.x1. What is the problem that we are having? Unless I'm forgetting how that is done, let me say unique. Yeah, you can check here for class matrix from last. X unique from last equaling to true. Yeah, I'll confirm this nini. Let me say from last equaling to false and run data from last equaling to false. From last equaling to true and run the data. It's not removing again. Yeah, I'll confirm this one. There's a way you can specify the exact column that you are referencing. Yenye unatumia for removing the duplicates. Just a minute. Let me answer. Hello, Maxwell. Hey, Maxwell. Hey, niko salama sana. Si tuende hapo saa 2:30? Hapana. Ushatoka unaenda? Ama ukami hivi? Ama unaenda tu tao? Hapana, magari za kutoka Thika zichelewangi. Tunapandia huko juu. Tunapandia huko juu kwa highway. Ni mimi niko na wewe. Hapo sawa. Ni venye niko na class nyingine hapa namalizia. Okay. Sawa. Yeah, okay. Sorry. Yeah, so we were supposed to be looking at this place. I've actually received the call and just remember that OBS is going to be recording the conversation. Uh-huh. So I'll check on this, but if you have if suppose you have any missing value, uh, it will not missing value, sorry, duplicates. I'm actually being distracted by the conversation we was having. But if it finds any duplicates in your data, it will remove it using that unique dot. There's somewhere we had duplicates. For example, line number 777, we created a data and called it students. And then if you view students, could not find function view. If you view this one, you can see number 1, 2, 2, 3, 3, 4, 5, 6, 6. So we have three duplicates. Duplicate here 4, 5. Now we have 2, 3 is also duplicate, and we have 8, 9 is also duplicate. All right. Sorry. Let's. Okay. Yeah. So you can see that if you try to do a unique, so students 1 and unique in bracket students, or let me just have it as students again, and run this one and view students SASA, you will could not find function view. So there's sometimes where R is accepting view ya small v, na sometimes it's accepting view ya capital V. I don't know why today it's, but now you can see 1, 2, 3, 4, 5, 6. It has actually referenced it using registration number. We wrote it as registration, but it should be registration, right? So that is cleaning using the unique. So it is removing duplicates. Similar to maybe here we were just trying to force some duplicates into the iris dataset that we always have, and then clean it using the unique, this one. But if you have any if you have any duplicates, for example, this one is really simple for you to understand. Use that. Use unique, and then you will clean it. Handling missing values, we've talked about na.omit. So these are the things we covered yesterday, right? We first added some missing values, and then so you create a problem, then solve the problem. Actually, that is how the world works. You create wars, and then come as the messiah. Yeah? After creating maybe a problem like creating COVID-19, and then you bring solution and get your money and go home. Beautiful. Okay. Another thing that you can do is you can modify classes of columns, right? You can do modification of the classes of columns. So the class of the columns of a data frame is another critical topic when it comes to data cleaning. There is a comment that James made. Okay, this one, under removing those missing values. In this example, I'll explain how to delete all rows with at least one NA value. If you have at least one NA value, it can be removed. But this method is called listwise deletion or complete case analysis, and it should be done with care. Statistical bias might be introduced to your results if data is removed without theoretical justification. But you can introduce statistical bias in your results. Suppose umetoa wale watu wenye ni wa maana. Ni kama mmefanya formation in OML1 and then wanatoa yule msee mlikuwa mnategemea, mtakuwa mmeua mbogi. So you can also modify classes of the columns, right? So for example, the class of columns of a data frame is another critical topic. So this example explains how to format each column to the most appropriate data type. So let's check at the data type of data, and you use what we call the supply or supply. Let me run the first this that we had here, and have we cleaned it really? Okay, yeah, we can just use that one and check on the classes. If we check classes here, we have it as numeric, character, logical. Though I didn't want it that way. But yeah, suppose maybe your kwa data yako x1 was supposed to maybe be like character, lakini imekuwa named as numeric. So that is where maybe this S apply helps you, right? So this one just first to check it, and then you can now use the type convert function to change the column classes whenever it is appropriate. So sometimes kama ilipata kama this one is a character na inafaa ikuwe numeric, and then now you use type convert function, it will convert it to the necessary class, right? Let me just run it this way, but this one will not offer much explanation. Oh, okay, yeah, now you can see. So initially unaona for example x1 imeandikwa as numeric, x1.1 imeandikwa as character, x1.2 pia ni character, x4 character, x5 logical. But now when we use this type convert, it is going to look at your data critically and check that is this supposed to really be integer or inafaa ikuwe different kind of data type, right? Yeah. And then now if you use that type convert, and then now it is going to convert it to what R thinks is the correct data type for your column. So type convert in bracket data, comma, as dot is true. What is this as dot is? Equaling to true. Yes? Anybody who thinks anything? But because of time, maybe you cannot listen to all of you. But Uh, check on what as.is means, and now if you run that, you can see that integer, character, logical, because type converter has already converted your data to. Let me see if as.is here, but I don't think it's written. Yeah, of course it cannot be there, but you can check. Oh, okay. Function for sanitizing elements of table produced by X table, used for dealing with characters which have special meaning and output. No, that is not what we are looking for. If type is latex. Yeah, but you can Google and check on this as.is. Another thing is also the last thing that you can do here is on detecting outliers, right? There's this outliers. I'd already explained what outliers does to your data set and how it makes it really read something that it should not be reading, right? So outliers are unusual values in your data set and they can distort statistical analysis. Now that is what Alvin was saying, that uh, what Alvin mentioned when the class started. Oh yeah, skewness. That it really introduces skewness to your data. So it can make your data to be skewed to the right, skewed to the left, and yeah, and it can violate your assumptions, right? The one method to detect outliers is provided by box plot. You can you can build a box plot and check if you have outliers, but then there is another functionality called boxplot.stats, where it is going to identify for you even the exact number, the exact value which is the outlier. If you run this uh, box plot air quality, you can see what you have. So when you build a box plot and see this, you can see number one, and then you can see number two here. You can see other two outliers also here, right? When you go to maybe something like SPSS, it can actually tell you the exact row number where that outlier is. For R, it is not telling you that, but it is just telling you where you can, I mean, the range or where the outlier is. So when you build a box plot can help you to identify. So we have this line of code. If you run it, it is telling you that the outlier is 99,999. Now I've given you the explanation to all the components of this part. All right. So we want to check outlier that is existing in row number one. So if you have like 10 numeric rows, then you can do this for all of them to check if you have outlier. I mean, right? But also look for how you can simplify if you have outliers in the all of your data set, so that you just do it one time. So there is data. So of course you are referencing the row that you want to use, right? And then check if inside this row we have an outlier. All right. Okay. So boxplot.stats in bracket data x1, this one, it calculates the statistics of the data in the column that we are using, in the column data.x1 column, using the boxplot method. It calculates the statistics. So these statistics include what? Lower and upper inches. Of course, that is the lower and the lower and upper quartiles. Calculate the whiskers and potential outliers, right? It calculates the statistical the statistics of the data here for a box plot is mostly what is the minimum value, what is the maximum value, what is the lower quartile, what is the upper quartile, what is the median, right? Those five. We talked about 5-point summary of a box plot, like a box plot does that. And then it now gives you again potential outliers. Then there's this one out. It is used to extract the potential outlier from the result of box plot dot stats data blah blah. data x1. This is just the column that we are referencing. We are talking about column x1 in our data, right? That is what out does. Out is used to extract the potential outliers from the result of the box plot.stat. And then another thing also that maybe this one percent in percent does, that is just an operator in R to check if the value is present in a vector, right? Yeah, so I think that is more of a breakdown on this part of on this line of code, I mean, right? So assume that maybe you have confirmed theoretically that the observation containing this outlier should be removed. Even before that, before we get to that, I hope you have understood all the sections of this line of code and how you can check your outlier, right? Stella, are you okay with the explanations that I've given here?
Yeah, I'm okay.
Yeah. Alvin?
Yeah, I'm good. I'm good.
Cool. Yeah, so you can do more on that. And then after checking, so suppose now you've checked and then you are confident that you found the outlier, then you can remove it using this line, right? Data, first just get to even have a look at it before I start talking. I might start talking immediately and you haven't looked at it for 10 seconds because we are actually stopping. Yeah, I hope you've seen that, right? So we want to remove the rows with outliers. The row that we found, and we found that it's 999 is the value. So it will also go through it and find where that 999 is. So the column is this data, is data x1, right? Is the x1 is the column, I mean. And then it checks if it found it in the stats that it did. If it found 999 in the stats that it did, right? And then it is going to extract it. And that is where we use this. You can see this exclamation mark, right? That we are adding to the initial line of code that we add. It's actually not very far from what we wrote here, right? It's not really different from what we wrote here. The only thing that we are adding now is this one, right? We are removing it from the data that we are working with. So if you run that and then maybe run data here, you can see that 999 has been removed and it was occupying row number. So 1, 2, 3, 4. No, number 5, right? Row number 5. Yeah, and you can see that it has removed even that row, right? So it removes everything because that it is an outlier. So it removes everything that is present there. I hope tuko sawa from what was supposed to be covered. You can go through hizi vitu zenye ziko hapa, we have actually covered them up here. So those are just extras. Tuko sawa? Yes? Yeah? Alvin, okay. Yeah, so I'm giving the assignment out today before I think I'll be on Transit, but I'll just upload it. It's something that you can upload. Actually, I can upload it right now, and it's going to challenge you a little bit. Uh, Kindly, that's why I'm giving it out now so that you work on it tomorrow. You work on it on Saturday and submit by uh, by what time? You have like 2 days to work on it. So submit it by midnight Saturday.
Sunday.
By midnight Saturday. And have a blessed week. Thank you so much. And next week we'll finish everything. Thank you.